So question 2 gives us 4 different expressions and we're asked to simplify those. And again, we're reminded that answers may not contain negative exponents. And another thing to remember is that answers should not contain any remaining giant ones, right? Simplification occurs when we've eliminated all possible giant ones. So if I look at this, I guess the thing that I'm probably going to do is I'll go ahead and square the x squared, right? So if let me just zoom in on, we'll just look at a. So if I square the x squared, that means I have 2x squareds, right? And certainly the shortcut would be that this is x to the 4th power, right? 2, 2, 2, 2. Or I'm sorry, x, 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 x to the 4th power. And then I'm multiplying that by 3 factors of x. And I've also got this y to the negative 7th power. Well, certainly I can combine the x to the 4th and x to the 3rd. That's a total of 7 factors of x. So I'm going to rewrite this as x to the 7th power times y to the negative 7th power. And to deal with this negative exponent, I'm going to choose to multiply this fraction by another fraction that's in the form of 1. And the form of 1 that I'm going to pick is y to the 7th power. Y to the 7th power. And if you look closely, you'll notice that in my numerator now, this is why I selected y to the 7th, I now have y to the negative 7th times y to the 7th, which equals y to the 0 power, which equals 1. So this just formed a 1 within that numerator. And in my denominator, I have 7 factors of y. So I can write this as x to the 7th, y to the 0 power over y to the 7th. But of course, this is just x to the 7th over y to the 7th. On question 2, let's see. I might choose to kind of look at some of the numerical parts first. In fact, I want to look at those separately. So in my numerator, I have an 8 and a 2. And in my denominator, I've got a 48 and a 4. So I just want to look at this numerical part first. I know that if I look at the number 8, 8 is a 2 times a 4. So I could consider this as just 2 times 4 in the numerator. And I can see at this point I do have a giant 1 of a 4 over a 4. So this will simplify to, let's see, in the numerator I've got 2 times 2 now, which is 4 over 48. And I believe that 4 times 12 is 48. 24 and 24 is 4. Yeah. So, and a 4 here. So when I look at this, you can see there is now this giant 1. And so in the top, I've got a 1. And my denominator, I have a 12. So I know that my final answer is going to involve 1/12. So I can go ahead and think about that, right? I've taken care of all of these numerical coefficients. And I know this just becomes a 1/12. So I'll just make a note of that to myself. And let's go ahead and look at the remaining problem. So in my numerator, I've got x y to the 8th. So there's an x and a y to the 8th. And my denominator, I've got y to the 12th power. Well, if I consider that y to the 8th over y to the 12th, if I was to expand that out, and I would have a giant 1 of y to the 8th over y to the 8th. So in fact, I might write it like this. So x times y to the 8th over y to the 8th times y to the 4th. It's kind of off. It's nice to offload that and just kind of look at it this way. Clearly, y to the 12th is y to the 8th times y to the 4th. And I now clearly see the giant 1. So I've got x over y to the 4th power. And I want to not forget my 1/12. So my answer then would be x over 12 and then y to the 4th power. Again, there's probably clearly there's other ways that you can do this problem, but this is the simplified version, the correct simplified version that we're looking for. Let's go to part C. Oh, interesting. it is nice that when I look at it, the exponent on these parentheses is a 1. So that's going to allow me, I don't have to worry about um, squaring these or cubing these fractions. So I can look at these fractions first. So I've got a 4 times a 6 over a 3 times a 2. Um, that 4 I'll write as a 2 times a 2. The 6 is a 3 times a 2. And for convenience, I'm going to rewrite my denominator as a 2 times 3. And the reason why I did that is now that I can see very clearly, this is this simplifies to just the number 4. And obviously, right, 6 times 4 is 24, and 24 divided by 6 is the number 4. But I like looking at it like this because it helps me practice what's happening when I'm looking at the variables as well. So my answer is going to have a 4 in the numerator and a 1 in the denominator. So let's look at the numerator in terms of the variables. I've got an a to the first power and an a to the fourth power. So in my numerator, I've got a to the fifth, and then there's a b to the third, and in my denominator, I have an a to the fifth. Well, I can see these form a giant 1. So I'm left with just 4b cubed for part C. There's a 4, got it, and there's a b to the third, got it. So 4b to the third power. And then finally part D. In D, I can see this 12 over 4. 12 is a 4 times a 3, and then I've got an x squared. In my denominator, I've got this 4, and I do have this x to the negative second, and I have this y to the second. So this is a giant 1, so the 4 is gone. In my denominator, to take care of this x to the negative second power, I'm going to multiply this fraction by x to the positive second over x to the positive second. Within my denominator now, when I look at it, when I multiply x to the negative second and x to the second, that equals x to the 0 power, which is the number 1. So that whole thing just simplifies to a 1. In the numerator, I have 3x to the fourth power, and in the denominator, there's still this y squared. So my answer for D is 3x to the fourth over y squared.